So hello students, welcome to my channel. Now in this video I am going to explain the term isothermal process. Now iso means equal and thermal, so this basically it is associated with the term temperature. So isothermal process is basically it is a process in which temperature is constant. Now as we know that we have three basic thermodynamical variables: pressure, volume and temperature. Now if any one of the thermodynamical variable is a constant, then other two variables will vary according to the gas equations. So as you can see in isothermal process, if temperature is constant, then pressure and volume they will vary. Now they will vary according to the Boyle's law. So which says that pressure is inversely proportional to volume. So this is one identifying mark for an isothermal process. Okay. Temperature will remain constant, pressure and volume they will vary according to the Boyle's law. Pressure is inversely proportional to volume. Now another identifying mark for this isothermal process is this process. In this process there is a exchange of heat. There will be exchange of heat between the system and surrounding. So there will be exchange of heat between the system and the surrounding, but this heat exchange will be very slow. Slow heat exchange. The heat exchange will be very slow. Now, so there is a slow heat exchange. Now, what does that mean? That means that suppose this is a container and it contains some gas. Okay. Now, if the process is isothermal, the condition will be this container will be a conducting container. The surfaces will be conducting. So, if heat is supplied to the gas, then at the same time this heat will be conducted to the surrounding, so that temperature of the gas will remain constant. Similarly, if heat is extracted from this cylinder, then again heat will flow to the cylinder or to the container from the surrounding. So again the temperature of this system will remain constant. Temperature will remain constant. Okay, so this is another identifying feature of an isothermal process. Now for isothermal process, as we have seen that temperature is constant and pressure and volume they vary according to this equation. So we have PV is equal to constant. PV is equal to constant. Now we are going to infer two things from this. Okay, now see, since PV is equal to constant, so if I differentiate this, pressure and volume both are variable, remember, only temperature is constant. So since both are variable, we have PdV plus VdP is equal to differential of constant as 0. Okay, so that gives dP by dV is equal to minus P by V. Okay, now dP by dV is the slope of PV graph, and slope of PV graph is negative. So slope is a decreasing slope. Okay, so that means if you have PV graph, so this line will represent an isothermal process, and this line is called an isotherm. Okay, and for this isotherm, the slope is minus P by V. Slope is minus P by V. Now another thing is, see, calculation of work done. Now work done as PdV, dW is equal to PdV. Now total work done in changing the volume from V initial to V final will be W equal to integral Vi to Vf PdV. Now if you substitute the value of P, this is nRT by V dV Vi to Vf. So this can be solved. So dV by V that is integration of dV by V is ln V. So this can be written as nRT ln Vf by Vi, final volume by initial volume. Now pressure is inversely proportional to volume. So in terms of pressure, this can be written as nRT ln, that is the natural log Pi by Pf. Okay. So in terms of, if work done in terms of pressure, it will be initial pressure by final pressure. In terms of volume, it will be final volume by initial volume. This you must not forget. Okay. So this is the expression for work done, and this is the slope for isothermal process.